Okay, higher derivatives. Turns out the derivative of a function is itself a function and so might have a derivative. And so we call the derivative of the derivative the second derivative. And the fun doesn't stop there. Let's take a look. This is basically what I just said. If we have a differentiable function, then its derivative is a function and so could have a derivative. And we call the derivative of the derivative the second derivative. There's a handful of different notations for the second derivative. One is f double prime of x. You'll also sometimes see y double prime. And perhaps the most interesting and confusing of the notations is this one here, d2y dx squared, which comes from the idea that it's the derivative of dy dx. So it's d dx, the derivative of the function dy dx. And if you put all that together, that's where you get the two d's, the d squared y in the numerator, and then the dx times dx squared. So it's bizarre notation. That's where it comes from. Just notation. They all mean the second derivative. And what is the second derivative? Well, the second derivative gives us the instantaneous rate of change of the derivative. And then the fun continues because the second derivative is a function, so it might be differentiable. What do we call the derivative of the second derivative? Well, of course, we call it the third derivative. And the derivative of that is the fourth derivative, etc., etc. And we, of course, need notation for these new concepts, the third derivative and fourth derivative and things like that. And it probably won't surprise you to know that we write the third derivative as f triple prime of x, or y triple prime, or d3y dx cubed. All different ways of writing the third derivative. We'll do one more, the fourth derivative, and at some point, there gets to be too many little tick marks to just write. You couldn't write the 100th derivative as f prime, 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 etc., etc., etc. And here's where we make the change. The fourth derivative is written as f with a little 4 in parentheses of x. That doesn't mean f to the fourth power. That means the fourth derivative. And all the ones after it are done the same. You don't tend to see the same kind of notation with a y. There's not some y to the fourth power in parentheses. But there is the notation d4y dx to the fourth. And that's pretty much all there is to it, except to try an example. Take the function f of x equals x to the fourth, and see if you can compute the derivative of f, the second derivative, the third derivative, the fourth derivative, the fifth derivative, and just for entertainment, see if you can compute the 900th derivative of this function f. So take a moment, see if you can complete this little list of derivatives, pause the video, and when you're ready, start it back up. And it probably didn't take you much to figure out that the derivative was 4x cubed, which makes the second derivative 12x squared. So the third derivative is 24x, and the fourth derivative is just 24. And the derivative of 24 is 0, so the fifth derivative is 0. And the sixth derivative is going to be 0. And the seventh derivative is going to be 0. And the 900th derivative, of course, is going to be 0. And all the other subsequent derivatives also 0. And that's all you need to know, at least for now, about higher derivatives. Told you it would be short. You are now in good shape to finish your homework on derivatives of polynomials. Looking forward to seeing you soon. Bye.